Good morning, all of you. Welcome to Sri Jayendra Rank Zone. Since we have done already lecture 1, that is general properties of 15 group elements. Now we are going to do lecture 2 of 15 group elements. So that is properties of nitrogen and preparation of compounds of nitrogen. Now we are going to do now. Just listen carefully. So please maintain your classwork so that whatever slides are shown to you, you can write it in your classwork. It is very, very important. That's why I'm giving here the notes also. It's the PPTs are nothing but the notes. So please go through it properly. Now coming to lecture 2, oxides of nitrogen. What are the various oxides found by nitrogen? As I already discussed, so nitrogen forms many oxides due to its small size, non-availability of d orbitals, and even high electronegativity. Due to high electronegativity, non-availability of d electrons, nitrogen forms many oxides due to the non-availability of d electrons and uh, high electronegativity, and high small size. So these are the 3 points based on that it forms many oxides. So various oxides of nitrogen you can see here. First, dinitrogen oxide. So it is N2O. It is also called as laughing gas. Here I'm writing this nitrogen oxide, laughing gas. It is also called as laughing gas. So if you inhale this gas for a few minutes, you'll get laughing automatically. So this is called laughing gas. So dinitrogen oxide, N2O, this oxygen state of nitrogen is +1, as I already told you. So nitrogen in its lower oxygen state is neutral, colorless gas, and it is neutral in nature, neutral oxide. And how it is obtained? By heating ammonium nitrate strongly, it forms nitrous oxide along with water. So this is the reaction. Next, nitrogen monoxide, NO, nitrogen monoxide. The oxygen state of nitrogen is +2, and it is also colorless gas and neutral. As I already told you, nitrogen in its lower oxidation states is always neutral, and the oxygen state of nitrogen is +2. How it is formed? It is formed by means of sodium nitrite on reaction with FeSO4 plus sulfuric acid. It forms Fe2SO4 taken twice, NaHSO4, that is sodium bisulfate, along with water and with nitrogen oxide, nitrogen monoxide. Next, dinitrogen tetroxide, that is N2O3. It exists as N2O5. Sorry, N2O6. Sorry, N4O6. Now, N4O6, the oxygen state of nitrogen is +3, so it is higher oxygen state, so it is acidic in nature, very, very important. And nitric oxide, nitrogen monoxide on reaction with N2O4, it forms dinitrogen trioxide. Next, dinitrogen pentoxide. And next, we have nitrogen dioxide gas. It is brown color gas, acidic in nature. Oxygen state of nitrogen is +4. So, lead nitrate on heating, it forms nitrogen dioxide, lead oxide, along with oxygen gas. So, these are all the preparations. Next, dinitrogen tetroxide. The oxygen state of nitrogen is +4. So, +3, +4, +5 states are acidic in nature, whereas +1, +2 states are neutral in nature. So which of the following is a neutral oxide? Which of the following is a neutral oxide? Which of the following is acidic oxide? Which of the following is basic oxide? They'll ask like these questions in the examination. So it is nothing but here N2O4 is +4 oxygen state, NO2 on cooling and heating it forms N2O4. And here from nitrogen dioxide also it forms. And here from nitric acid, phosphorus pentoxide, that is P4O10. It is called as P2O5. So it combines to form HPO3, that is phosphorus acid, along with nitrogen pentoxide, that is dinitrogen pentoxide. So these are the various oxides of nitrogen. In this oxide, they'll ask the oxygen states of nitrogen, structures of nitrogen, as well as the chemical nature of nitrogen. So chemical nature, it is not chemical nature, it is chemical nature. So chemical nature of nitrogen is neutral, acidic, and acidic. So nitrogen in its higher oxygen states is acidic in nature, whereas nitrogen in its lower oxygen state is basic in nature. Sorry, neutral in nature, not basic. All non-metallic oxides generally they are acidic in nature, but some non-metallic oxides are neutral in nature. That is, the non-metallic oxides with the oxidation number lower, the lower oxidation number for non-metal are said to be neutral in nature. The non-metallic oxides with the lower oxidation number on non-metal are said to be neutral in nature. I hope it is clear. So this is very, very important. Let us see the structures of this now. Structures of dinitrogen. So this is nitrous oxide. This is also called as laughing gas. This is a structure, this is a resonance structure. It has two resonating structures, N double bond, N double bond O, N triple bond, N single bond O. It can be either this or this, both are same. So its shape is linear. Shape is also linear. So it undergoes sp2 hybridization, sp hybridization, sorry. It is shape is linear. And next NO. NO is N double bond O. So it is having N double bond O, N single bond O, bond length is 115 picometers, and here 113 picometers, 190 picometers. These are not required, only the structure is important. Next N2O3 structure, N double bond O, N double bond O. So this is the structure of N2O3. This can be witnessed like this also. For this nitrogen, you'll get single bond, and for this nitrogen, you'll get single bond with oxygen. These two are resonating structures, and this double bond O is common in both the cases. So the shape is planar. The shape is what? Planar with the bond length 105 degrees, 130 degrees, bond angles. Everything they can ask for IIT advanced level, they can ask even minute point also. So that is why all the points are very, very important for the examinations, competitive examination especially. So so they'll ask the question like this. In N2O3, nitrogen combines with oxygen, means the bond between nitrogen and oxygen is double bond or triple bond or single bond, they'll ask. So two oxygens double bonds and one oxygen is single bond. So the structure also they'll ask, and how many lone pairs. See, this nitrogen is having one lone pair. This nitrogen has no lone pairs because 2 plus 1, 3, 3 plus 1, 4. And here it should have one more electron. This nitrogen has one lone pair, 1 plus 2, 3, so it has one lone pair. And this nitrogen does not have lone pair, and the one more electron will get for oxygen. So that's why this electron is migrated towards oxygen. So it has no lone pairs, it has one lone pair. Here also, it has one lone pair, that is three electrons, one lone pair here. This is one lone pair. It contains one lone pair. So the number of lone pairs in NO is on nitrogen atom is 1. The number of lone pairs on oxygen atom is 2. And it is 3 actually. This should be equal to 3. Actually, it should be 3. And so on. So they can ask lone pairs, bond angles, anything they can ask, and even bond lengths also they can ask, bond length, and even sometimes they'll ask bond order also. So bond length and bond length order also they'll ask. So all these 4 points are important in the structures. So you have to note down all these 4 points in the structures. I hope it is clear. Let us see some more oxide structures of nitrogen. Oxides of nitrogen. So NO2, N double bond O, single bond O. With one oxygen, it is single bond. With one oxygen, it is double bond. So 3 electrons already here. Total, it has 5 electrons. But this one more electron is going here, and so one more electron is left here. So one electron left on nitrogen dioxide. So double bond O, double bond O. This oxygen is having 6 electrons. Means it is oxygen is not giving any electron. Only nitrogen is giving 2 electrons. That's why single bond. You have to note down that. So this is brown color gas, reddish brown color gas. That is nitrogen dioxide, and its shape is angular. Shape is angular. Bond parameters 134 picometers and 120 picometers. NO bonds are 120 picometers. And here N2O4. N2O4 structure, N double bond O, single bond O, single bond O. Even they can ask this also. Number of sigma bonds and pi bonds in N2O4. So sigma bonds and pi bonds in N2O4 means here one sigma, one pi, here one sigma, one pi, here one sigma, one sigma. So total 4 sigma bonds and 2 pi bonds. So it is how much? 4 sigma bonds and 2 pi bonds. They can ask even this type of question. Any question they can ask in the examination. So the shape is planar. And next N2O5, it has how many sigma bonds and pi bonds, that also you can see. So NON, it has NON bonds. Which are the following contains NN bonds, NON bonds. So NN bonds in N2O4, NON bonds in N2O5, NON bonds. N single bond O, single bond N. So oxygen, two sides, it is giving 2 to 1 electron. So it is N single bond O, single bond N. So this is also important, and this is N single bond N, and this is only one nitrogen, so now we have to consider this. So here NO, 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 NO. So here 1 sigma, 1 pi, 1, 2, 3, 4, 5, 6 sigma bonds. 6 sigma bonds. How many sigma bonds? 6 sigma bonds. And how many pi bonds? 2 pi bonds. So these are the number of sigma bonds and pi bonds. Even they'll ask this also in the examination. The structure is planar. I hope it is clear. So in the structures, they can ask either the structure, they ask lone pairs and bond pairs, they ask shape, or they can ask bond lengths, and they can ask number of sigma bonds and pi bonds. So all these structures are important, and most important is structures of phosphorus and sulfur. Oxy acids of sulfur and phosphorus are most important, but we have to study everything, because if you are going for writing IIT advanced, they can give any question they can give. So with all the points, you have to be thorough with this. So that's why for NEET also it's very important. So whatever points we have discussed, please note it down. Next, oxyacids of nitrogen. Nitrogen has forms four oxoacids. Oxoacids, not oxyacids. It's called oxoacids. It can form four oxoacids, that is hyponitrous acid, nitrous acid, nitric acid, pernitric acid. So in all this, which is more acidic also we are going to discuss now. So that also we'll do now. So let us see the oxoacids of nitrogen. So hyponitrous acid, H2N2O2, nitrous acid HNO2 is the structure. How many OH bonds? So it is, since it has two OH bonds, its basicity is 2. As the acids will have, so basicity they will ask. The basicity of nitrous acid is, since it has only one OH bond, so basicity is equal to 1. Basicity is equal to 1. And here basicity is 2, it has one hydrogen. So next, nitric acid, its basicity is 1 again, because it's OH, one OH bond is there. So basicity is equal to 1. And for the last one, basicity is 1 again. So hyponitrous acid basicity is 1. They may ask basicity also, and they may ask without giving formula, what is the basicity of pernitric acid? It is equal to 1, because the formula of pernitric acid is HNO4. The structure will be like this. And number of sigma bonds and pi bonds in pernitric acid: 1 sigma, 1 pi. 1, 2, 3, 4 sigma bonds, 1 pi bond. So it contains 4 sigma bonds, 1 pi bond, because one double bond contains 1 sigma, 1 pi, and the remaining single bonds contain 1 sigma bond. Similarly, how many OH bonds, how many NO bonds are there? NO bonds 1, 2, 3. So NO bonds 2 bonds are there, and here NO bonds only 1. N double bond O bonds 1. Like this, they can ask N double bond bonds or N single bond O bonds or anything. So you have to be thorough with entire structure. How many lone pairs? It has one lone pair, and here for this it has one lone pair, and here no lone pairs, and here no lone pairs. So no lone pairs on nitrogen for nitric acid as well as pernitric acid. There is no lone pairs. Whereas for nitrous acid, lone pairs are there. Hyponitrous acid also, lone pairs are there. And basicity is 2, basicity is 1, basicity is 2, 1, basicity is 1. Only for hyponitrous acid, basicity is 2, because it is containing 2 OH bonds. And all these are acidic in nature. And most acidic, strong acidic is this. Nitric acid is strongly acidic when compared to pernitric acid. Second one is pernitric acid, and third one is nitrous acid. So you can see the oxygen states of nitrogen. So in this, the oxygen state of nitrogen is 1, and here one peroxy bond is also there. In high pernitric acid, we have one peroxy bond. Peroxy bond means where oxygen is linked by single covalent bond. So this is called peroxy bond. This is OOH is peroxy bond. This bond is called peroxy bond. I hope it is clear. So all these points are very, very important. So we have completed oxyacids of nitrogen now. Oxoacids of nitrogen. Next, preparation of ammonia by Haber's process. Ammonia is formed by the decay of nitrogenous organic matter. So here urea is nothing but NH2CONH2. On combination with water, it forms ammonium carbonate, which on further decomposition forms ammonia, water, and carbon dioxide. So ammonia is formed by the decay of nitrogenous organic matter. This is called nitrogenous organic matter, that is urea. Urea on hydrolysis, you will get ammonia gas, that is foul smelling gas. Ammonia is getting, it's a foul smelling gas. Foul smelling. Even they can ask for test also. So if you decay nitrogenous organic matter, that is urea, so NH2CO NH2. So this is called nitrogenous organic matter. By decaying it, you will get ammonia gas, that is foul smelling gas. Any ammonium salt with caustic soda, ammonium salt, that is ammonium chloride, ammonium sulfate, ammonium chloride, ammonium sulfate, etc. These are called salts. Any ammonium salt with caustic soda or calcium hydroxide on heating forms ammonia gas along with sodium sulfate and calcium chloride. I hope it is clear. So any ammonium salt with caustic soda gives ammonia gas. For this equation, they give ammonium salt A on reaction with B forms ammonia plus sodium sulfate plus water. So they'll ask what is A and B in the given equation. What is A? What is B? A is ammonium sulfate and B is caustic soda. When they are given sodium sulfate, you have to take caustic soda. If they are given calcium chloride, we have to take calcium hydroxide. So they can ask, identify the following in the given equation. That is, what is A? What is B? Ammonium salt they give. Ammonium salt they give. But ammonium salt only A, and ammonium salt A combines with B to form ammonia, sodium sulfate, and water. What are A and B? Like these questions also you may expect like these questions also. That's why these equations also you have to learn completely. Definitely they are very very important. So what are the important reactions for the competitive exam, that only we have given. So what is the test for ammonia? It is a false spinning gas. Ammonia is formed when ammonia is treated with, so HCl, it forms ammonium chloride, white precipitate. That is also a test for ammonia. Anyway, we are going to discuss for ammonia test. Next, preparation of ammonia. Ammonia is manufactured on large scale by Haber's process. In this, they'll ask what is the catalyst, what is the promoter, what are the temperatures, and what are the pressures. So these four topics are very important. So ammonia is manufactured on large scale by Haber's process. So nitrogen combines with hydrogen and forms ammonia. So it is exothermic reaction. Delta H is equal to minus 92 kilojoules. The optimum temperature is 700 to 750 kelvins. So this is the optimum temperature. They'll ask the optimum temperature. High pressure, that is 200 atmospheres. Catalyst is finely divided iron surface, and catalytic promoter is molybdenum or potassium oxide or aluminum oxide. Any three we can use. All the anyone we can use from all these three. So this is called preparation of ammonia by Haber's process. So in industry, ammonia is manufactured on large scale by using Haber's process. I hope it is clear. So all these conditions are most important. So please note it down in your classwork. They can ask from the objective exam also. It is a reversible reaction. So by reversing the conditions, we can get again the same reactants. Next, this is the Haber's process. So one volume of nitrogen and three volumes of hydrogen will be will be taken in a container, and here we'll get compressor where you get pressure. This nitrogen gas and hydrogen gas is highly compressed by using high pressure, that is 200 to 900 atmospheres. So in this pressure, what happens then, they'll go to catalytic converter, that is ammonia converter. So catalyst at 700 kelvins, it forms ammonia. This ammonia gas is being condensed, and then finally you'll get liquid ammonia gas, liquid ammonia. And this water, the nitrogen and hydrogen is left over, it is recirculated again, and again the reaction takes place like this. So this is liquid ammonia is formed, and where it is being, whatever the leftover nitrogen and hydrogen left over in this condenser will be recirculated again, the recirculation pump, so that this nitrogen and hydrogen again combines it, again passing through a compressor by applying high pressure, and catalytic converter. This is the catalyst where you have catalytic converter, where you have iron and molybdenum is present in this converter. So again, by means of condenser, again it forms liquid ammonia. I hope it is clear. So this is called Haber's process, preparation of ammonia. It's very very easy. Only the conditions are important. Next, properties of ammonia. Ammonia is a colorless gas with pungent smell. As I told you, foul smelling gas, that is called pungent smell. So ammonia is a colorless gas with pungent smell, and its freezing point is 198.4 kelvins and boiling point is 239.7 kelvins, which is less than 0 degrees C. So ammonia is gas at room temperature. So that's why its boiling point and freezing point is very very less. It has high boiling point due to intermolecular hydrogen bonding. Actually, it is less when compared to normal gases, but in when compared to gases, it is, when compared to normal substances, it is less because it is less than 0 degrees, because 273 kelvins is 0 degrees. But within the gas, it has high boiling point due to intermolecular hydrogen bonding, because nitrogen, it has hydrogen bonding with, sorry, hydrogen has bonding with nitrogen. So this is called intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Ammonia is highly soluble in water, and its aqueous solution is called weakly basic. That's why it is, ammonia is basic in nature, because when dissolved in water, it forms ammonium ion along with OH minus ions. As it is giving OH minus ions, so it is basic in nature, and it is giving aqueous OH minus ion, that is actually not much concentrated. That's why it is called weakly basic in nature. It is not a strong base, it is a weak base when compared to KOH or NaOH, etc. I hope it is clear. So these are the points of ammonia. Next, structure of ammonia. In ammonia, nitrogen is of sp3 hybridization. Already we know nitrogen has three bond pairs and one lone pair. So due to this lone pair, it has pyramidal shape, not the tetrahedral, and bond angle is 107 degrees. So it undergoes sp3 hybridization. So this is the structure of ammonia. It has three bond pairs, one bond pair, two bond pairs, three bond pairs, and one lone pair. Due to the presence of lone pair, the bond angle is decreased from 109 to 107 degrees, and the shape is expected to be tetrahedral as it is undergoing sp3 hybridization, but it takes the shape of pyramidal shape. It takes the shape of what? Pyramidal shape. I hope it is clear. Next, chemical properties of ammonia. Ammonia is very important compound. So it is used as reagent in inorganic qualitative analyses for the analysis of basic radicals. So to obtain basic radicals, we have to use ammonia is used as reagent. So zinc sulfate on reacts with ammonium hydroxide, it forms zinc hydroxide white color and ammonium sulfate aqueous. So if we take zinc sulfate along with ammonium hydroxide, it forms white precipitate that is due to the formation of zinc hydroxide. So it is used for testing basic radicals. What are the basic radicals? SO42 minus, Cl minus, and this. So Zn plus 2, Fe plus 3. So it forms ferric hydroxide and ammonium chloride aqueous. Copper ions on reaction with ammonia, it forms deep blue solution due to the formation of complex compound called copper ammonia. So it has tetraamine copper cupric ion. So tetraamine cupric ion is deep blue solution. Silver nitrate, silver amine. So diamine silver chloride. It is nothing but white precipitate of silver is treated. This is also a form a complex compound. So these are the uses of ammonia. So to identify silver and to identify copper, to identify iron, to identify Zn. So we can test zinc, iron, copper as well as silver by using ammonium hydroxide, by using ammonia. Ammonium hydroxide, how we get? When ammonia is dissolved in water, it forms ammonium hydroxide. So when you take ammonia along with water, it forms ammonium hydroxide already. So it forms ammonium hydroxide. This ammonium hydroxide, I'm not writing balancing equation, just for understanding I'm telling. So this ammonium hydroxide combines with the basic radicals and forms precipitates of different colors. So with copper, it gives deep blue solution. With silver, it forms precipitate complex compound, and with zinc it forms white precipitate. With iron it forms green precipitate, green color. So in this way you have to take. I hope it is clear. Next, use of ammonia. In the manufacture of nitrogenous fertilizers like urea, that is NH2CO, NH2, ammonium nitrate, ammonium sulfate, etc. Liquid ammonia is used as refrigerant. So these are the compounds of nitrogen. We have done oxo acids of nitrogen, oxo acids of nitrogen, oxides of nitrogen, preparation of dinitrogen, and ammonia, preparation of ammonia, properties of ammonia, and also uses of ammonia. So we have done up to compounds of nitrogen. I hope it is clear. Next, we have nitric acid preparation. So one more compound of nitrogen, we have HNO3. So nitric acid is prepared in the laboratory by reacting nitrate salts with concentrated sulfuric acid. So sodium nitrate, potassium nitrate with concentrated sulfuric acid. Concentrated sulfuric acid is important so that you will get nitric acid. So this is the preparation of nitric acid. All the preparations reactions they can ask in the examination. So with all the reactions you have to be thorough. Next, nitric acid Ostwald process. This is very important for the examination. Ostwald's process of preparation of nitric acid. So ammonia is catalytically oxidized to nitric oxide. When ammonia is treated with oxygen in the presence of platinum gauge at 500 kelvins and 9 bars pressure, it forms nitric oxide and water. This nitric oxide combines with oxygen to form reddish brown color gas. This is called reddish brown color gas. So reddish brown color gas called nitrogen dioxide. Nitrogen dioxide. This nitrogen dioxide, when dissolved in water, it forms nitric acid along with nitric oxide. So neutral oxide along with nitric acid. So this is called preparation of nitric acid by Ostwald's process. Three steps. First, it starts with ammonia and forms nitric acid. So ammonia on reaction with on oxidation in the presence of catalytic platinum gauge, it forms nitric oxide. This nitric oxide is further oxidized to nitrogen dioxide, reddish brown color gas. This nitrogen dioxide gas, when dissolved in water, forms nitric acid. I hope it is clear. So this is the preparation of nitric acid by Ostwald's process. Next, This is the manufacturing. This is the platinum gas. One volume of ammonia and 8 volumes of oxygen is taken in the container, and in the presence of platinum, it forms nitric oxide, colorless gas, colorless neutral gas, and this nitrogen dioxide is combined, it is sent into the oxidation chamber where it gets further oxidized to nitrogen dioxide. Here it forms reddish brown color gas. This reddish brown color gas is going to absorption tower where you have water is sprinkled from the top. Water is sprinkled from the top, due to which what happens, this nitrogen dioxide combines with water and forms nitric acid. And here this is quartz gas, and these are waste gas will go off like this. Nitric oxide is going like this, and nitric acid is formed here. So this is called preparation of nitric acid by Ostwald process. The catalyst is platinum gauge. I hope it is clear. Next, structure of nitric acid. So nitric acid is a colorless liquid with a freezing point of 231.4 kelvins less than 0 degrees and boiling point of 355.6 kelvins greater than 0 degrees. In gas state, it exists as planar molecule. This is a planar molecule as it contains one OH ion, one OH bond. So it is nothing but base city is nitric acid is 1, and nitrogen atom in nitric acid is sp2 hybridized. Here it is very important. The hybridization of nitrogen in nitric acid is sp2 hybridized. sp2 hybridized, shape is planar molecule, and base it is 1. So all these points are important. Next, chemical properties of nitric acid. Concentrated nitric acid is a strong oxidizing agent. It oxidizes metals to respective metal nitrates. The products of oxidation depend upon the concentration of the acid, temperature, and nature of the metal. So all these concentrated nitric acid we have done. So these concentrated nitric acid reactions are most important because they'll ask in the examination the byproducts they'll ask. So you have to underline this, very, very important. All the oxides of nitrogen will come. So if you take copper along with nitric acid, it forms nitrogen oxide. If you take hot and concentrated nitric acid, you'll get nitrogen dioxide. And if you take dilute nitric acid, very dilute nitric acid along with zinc, you'll get nitrous oxide. And if you take concentrated nitric acid, you'll get again nitrogen dioxide. So when you are taking concentrated nitric acid, you are getting nitrogen dioxide, that is reddish brown color gas, by reaction with metals like copper and zinc. When you take dilute nitric acid, you will get nitrous oxide or nitrogen oxide. So this is nitrogen oxide, nitrogen monoxide, or nitrous oxide. So they can ask any equation. So these things are common, that is copper nitrate, and zinc nitrate are common, but these gases are different, and water molecule is also common. So these gases, so that's why all these reactions are very important. In the examination they can ask these reactions. What happens when copper is treated with hot and concentrated nitric acid? It gives reddish brown color gas which is formed due to the formation of nitrogen dioxide. What happens when copper is treated with dilute nitric acid, very dilute nitric acid? So with very dilute nitric acid, it forms nitrogen monoxide. What happens when zinc is treated with very dilute acid? It forms nitrous oxide. With copper, it forms nitrogen monoxide, and with zinc, it forms nitrous oxide. And with hot and concentrated, it is common for both copper and zinc. It is nothing but due to the formation of nitrogen dioxide. When you take concentrated nitric acid, you will get nitrogen dioxide as product. When you take dilute nitric acid, you will get either nitrogen monoxide or nitrous oxide depending on the metal. With copper, it gives nitrogen monoxide, whereas with zinc, it is giving nitrous acid, that is laughing gas, nitrous oxide. So I hope it is clear. So all these points are very important. So please note down in your classwork. Whichever I have underlined the reactions, please note it down. It oxides metals to respective metal nitrates. The products of oxidation depend upon the concentration of the acid, temperature, and the nature of the metal. So with copper, it forms nitrogen monoxide. With zinc, it forms nitrous oxide. So that is N2O laughing gas. When you take very dilute nitric acid with copper and zinc, when you take hot and concentrated nitric acid with copper and zinc, the products are same. That is nitrogen dioxide, nitrogen dioxide. I hope it is clear. Next, chemical properties of nitric acid continue. So concentrated nitric acid oxidizes non-metals. It oxidizes iodine to iodic acid. Oxidation. So iodine to iodic acid plus NO2 plus H2O, NO2. Whenever you take concentrated nitric acid, one thing you have to remember, whenever you take concentrated nitric acid, the byproduct is NO2, 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 and NO2. So definitely you will get nitrogen dioxide because it loses its acidic character. Because NO2, when you dissolve in water, what happens? It forms nitric acid. So that's why definitely it should have to dissolve into nitrogen dioxide. So whenever you take concentrated nitric acid blindly, you can take the one of the byproduct is NO2. So iodine changes to iodic acid, sulfur changes to sulfuric acid, and phosphorus changes to phosphoric acid, and carbon changes to carbon dioxide. Carbon dioxide is also acidic in nature. So when you take concentrated nitric acid, you will get acids only, corresponding acids on reaction with non-metals. So all these reactions are important. So please note it down. The reactions of concentrated nitric acid are very, very important. Definitely they'll ask the questions in the examination. So this which type of questions they'll ask, that also I'll discuss with you. I hope it is clear. Next, ground ring test. Very, very important. This we are going to perform in the lab also. So what is ground ring test? We are discussing now. Nitrate ions are detected by nitrate ions NO3 minus. What are nitrate ions? It is nothing but what? NO3 minus. NO3 minus ions are detected by brown ring test. Nitrate salt solution is added to freshly prepared ferrous sulfate solution. So when the nitrate salt can be sodium nitrate, potassium nitrate, or magnesium nitrate, anything. So nitrate salt solution is added to freshly prepared ferrous sulfate solution. So this is called ferrous sulfate solution. So Fe plus 2 state. The concentrated sulfuric acid is added along the sides of the test tube. If you add after adding nitrate salt solution to freshly prepared ferrous sulfate solution, you have to add sideways slowly along the sides of the test tube. What you have to add? Concentrated sulfuric acid dropwise, slowly, dropwise. So a brown ring appears at the junction of two liquids. Which junction? Which liquids? That is nitrate salt solution and ferrous sulfate solution. In between these two, a brown ring is appears at the junction of two liquids, which confirms the nitrogen nitrate ions. Which confirms the nitrate ions. So this is called brown ring test, and the brown ring is formed due to ferrous. So it is ferrous H2O taken 5 times, penta-aqua, nitrogen monoxide, penta-aqua, so 5 water molecules along with ferrous. So due to the formation of this compound, even they'll ask this also in the examination. When nitrate salt solution is added to freshly prepared ferrous sulfate solution, followed by concentrated sulfuric acid, a brown ring is formed. And the brown ring is formed due to the formation of what is the formula of the compound, complex compound formed due to the brown ring? That is iron, penta-aqua. This is 5 water is there, so we call it as penta-aqua iron. That is ferrous nitrogen monoxide. So nitrogen monoxide, this is the formula of the compound. Definitely they'll ask this formula in the examination. So please remember this formula. So FeH2O taken 5 times NO plus 2 charge along with water. So the brown ring is formed due to the formation of this compound. And this brown ring is formed at the junction of the two solutions. Two solutions means at the junction of the two liquids. I hope it is clear. So very, very important bounding test. You will do it in the lab also. So easily can remember. But in competitive, they will not ask what is formed. They will ask either they can ask two questions based on this. What is the first question? When nitrate salt solution is added to freshly prepared ferrous sulfate solution along with constant sulfuric acid. First option they will give a brown ring is formed at the junction of two liquids. So the brown ring is formed. That is the answer. Like that, they can give options, or even they can give the brown ring is formed when this nitrate solution is added to freshly prepared ferrous sulfate solution along with concentrated sulfuric acid is due to the formation of which compound? Due to the formation of, definitely they'll ask this complex compound formula. And the formula of this complex compound is FeH2O taken 5 times NO plus 2. Charge is plus 2. So iron is in plus 2 state. I hope it is clear. Very, very important. This is bounding test. Next, use of nitric acid. It is used in the manufacture of nitrogen fertilizer like ammonium nitrate. It is used as nitration mixture. Actually, it is not nitrating mixture. It is nitration mixture. Nitration mixture means what? What is nitration mixture? It is one part of concentrated sulfuric acid and one is to the ratio. That is along with concentrated sulfuric acid. It is called nitration mixture of an organic compound. So nitrogen mixture means 1:2 ratio of concentrated sulfuric acid along with concentrated nitric acid. Concentrated sulfuric acid. This is called nitration mixture. It is used in organic compounds, in the nitration of an organic compound. It is used in preparation of nitroglycerin, TNT, trinitrotoluene, etc., which are explosive compounds. It is used in was. TNT means trinitrotoluene. Trinitrotoluene. It is used as an oxidizer in rocket fuels. So these are the uses of nitric acid. All the uses of nitric acid. I hope it is clear. Next, example one. HNO2 acts as both oxidant as well as reductant. Explain. So the oxygen state of nitrogen is HNO2 is plus 3, so that's why it can act as an oxidant as well as reductant. Because nitrogen in higher oxygen state can act as acidic nature, and when HNO2 it is also acting as reductant because of the presence of hydrogen. Next question. Why nitrous oxide support combustion more vigorously than air? Nitrous oxide support combustion more vigorously than air. Nitrous oxide is formed as N2O. So nitrogen oxide on decomposition produces oxygen about one third of volume. So that's why it is vigorously more vigorous than air. Supports combustion because due to the production of oxygen, it supports combustion. So now we're taking you to the previous slide. So we'll discuss. So in this session, we have completed completely about nitrogen. Next session, we will complete completely about phosphorus so that this chapter will be completed. And all these points are very important. So I would like to discuss some questions based on nitrogen. So what are the questions based on nitrogen we are going to discuss now? So next we will discuss compulsory phosphorus. So the previous questions based on nitrogen we are discussing now right now. So I'm writing here nitrogen along with compounds of nitrogen. So first question number one, ammonium nitrate. These are the previous competitive questions. Ammonium nitrate, ammonium nitrate on heating gives. So ammonium nitrate on heating gives. First option nitric oxide, second option nitrogen oxide, second option nitrogen, third option nitrous oxide, and fourth option N2O4. So I told you no, as reactions are very, very important. So ammonium nitrate on heating forms nitrous oxide only. On heating forms nitrous oxide. Second question. The paramagnetic oxide among the following. This is also they asked. Paramagnetic means which contains lone pairs. So paramagnetic oxide among the following is. So these are the different competitive questions they will ask in the examination. This is previous JEE mains question. Paramagnetic oxide among the following is option 1, that is N2O, option 2, that is N2O3, option 3, that is NO, and option 4, it is N2O4. So they are asking which is paramagnetic oxide. Paramagnetic oxide means which contains lone pairs. It should contain what? Lone pairs. So lone pair is containing for only this nitrogen monoxide because N double bond O, and it has how many lone pairs? Here actually two only. So it has like this. These are the lone pairs. So which contains lone pairs. So this is why it is paramagnetic in nature. I hope it is clear. Next question. Question number 3. Which of the following is a mixed anhydride? Which is a mixed anhydride? Anhydride means removing water molecules, adding water molecules. So first one nitrogen dioxide, second one N2O3, third one N2O5, and fourth one N2O. So answer is NO2 because NO2 on dissolving in water it forms HNO3 only. That's why it is called a mixed anhydride HNO3. I'll make it clear. HNO3. So this nitric acid is HNO3. I hope it is clear. So answer is NO2. Next. So like these questions are most important for the examination. Question number 4. So based on nitrogen, I want to discuss all the questions because very less questions I have given in the PPTs. So I'll do questions more on here. So please note it down all the questions. Now match the following. List 1 and list 2 is given. These type of questions are also important for inorganic chemistry. So list 1, list 2 is given. First option A, they have given 4NH3 plus 5O2 gives rise to. I have given all the reactions they have given here gives rise to. Option B, P4 plus 3NOH plus H2O, 3H2O. This reaction 2. Again, I'm writing here. Plus 3H2O gives rise to. Option C, NH4 ammonium nitrate on heating strongly gives rise to. Option D, lead nitrate on heating strongly gives rise to. So they can ask any equation as I told you. And here also they have given the products also. That is option 1, PbO plus NO2 plus H2O. Option 2, N2O plus H2O. It is not that much simple as you seen. Option 3, N2O5 plus H2O. Option 4, 4NO plus 6H2O. Option 5, 3NH2PO2 plus PH3 phosphide. So the correct match they are asking. Correct match is, the correct match is A is 4, B is 5 because A is NH3 plus 5O2 gives us to NH2PO2 plus, NO plus 6H2O because ammonia on reaction on oxidation forms nitrogen monoxide. So A is 4, B is 5 because phosphorus is there, so it forms phosphine. And C is, A is 4, B is 5, and C is 2, that is ammonium nitrate on heating strongly, it forms nitrous oxide plus water. So, and D is 1. So this is the right answer. PB nitrate, lead nitrate forms PbO. Anyway, lead is there, so straight away we can say D is 1. So this is the right option. I hope it is clear. So like these questions are also very, very important. So this question has come from Neet. This is previous Neet question. So like these questions they ask in the examination. I hope it is clear. Next question, question number 5. So please note down all these questions in your classworks. Which of the following oxides of nitrogen? This has come again for Neet. Which of the following oxides of nitrogen is a brown colored gas? Is a brown colored gas. So first option, nitrogen dioxide. Second option, nitric oxide, nitrogen monoxide. Third option, N2O. And fourth option, N2O5. Since we have done the class just now, so that's why easily we can remember the answer is reddish brown color gas is nitrogen dioxide. But in the final exam, You have to remember all these things. I hope it is clear. So reddish brown color gas is nitrogen dioxide. Next question. Of the following, this is also previous NEET question. Of the following, so they can ask any question based on equation structures, everything. This question is based on structure only. Of the following, which has three electron bond in its structure, which has three electron bonds, three electron bond in its structure. So all these questions are important for competitive. So they are asking which has three electron bond in its structure. First one they have given N2O. Second one they have given nitric oxide, that is nitric oxide NO. And third one they have given dinitrogen trioxide, that is N2O3. And fourth option they have given nitrogen pentoxide N2O5. So which has three electron bond. So this is very important question. So out of the following, which has three electron bond in its structure. So three electron bond in its structure is nitric oxide. So it is nothing but nitric oxide because it has, as I told you, N double bond O, it has three electron bond, three electron and one bond. So it is nothing but nitric oxide. So you have to be thorough with the shapes. From the shapes also they are going to ask the exam questions. So that's why I told you. Very important all the structures. Next question. Question number 7. Question number 7. So again they are given list 1, list 2 for NEET exam. List 1 and list 2. You have to identify the correct match. So please, we are going to discuss all these points. Very important these questions. So A, they have given NO. B, they have given NO2. C, they have given N2O3. So from oxides and hydrates, we are getting many questions. And 4, they are given N2O5. And here, list 2, they are given first one, colorless and paramagnetic. Colorless. So this property is very important. So if you remember this question, it's more easy. Colorless and paramagnetic in nature. That is option 1. Second option, greenish yellow color gas. Greenish yellow. You can see here, this is a new one. Greenish yellow colorless, yellow color gas. Third one, reddish brown and paramagnetic. Reddish brown and paramagnetic. Reddish brown and paramagnetic. And fourth option, they have given anhydride of nitric acid. Anhydride of, like these questions, even you can expect for NEET as well as IIT. So that's why they'll give matching, matrix matching question type. So fifth one, anhydride of nitrous acid. Anhydride of nitrous acid, that is HNO2. So these are the 5 points. Now they're asking correct match. So A is nitrogen oxide. It is colorless and paramagnetic. We already know. So A is 1. Answer I'm writing here. So please note down this answer and question in your classwork. A is 1 and B is 3. What is the answer for B? Nitrogen dioxide. It is reddish brown and paramagnetic. Already we know. So B is 3. So even nitrogen dioxide is also paramagnetic because it has one electron deficit. So sorry, this is N double bond O and NO. So it has one electron, one lone pair of electron. That's why it is paramagnetic. So this is nitrogen dioxide. Next N2O3. So that is C. So what could be the C? N2O3. C is 5 anhydride of nitrous acid. That is HNO2. So it is N2O3 when dissolved in water, it forms HNO2. So C is 5 and D is, what is D expected to be? N2O5, it is 4 anhydride of nitric acid. So answer is A1, B3, C5, D4. A1, B3, C5, D4. So all these are very important. So this question, like these questions you will expect in the examination. So please do like these questions more and more. I hope it is clear. So nitrogen monoxide is colorless and paramagnetic. Nitrogen dioxide is reddish brown and paramagnetic. dinitrogen trioxide is anhydride of nitrous acid, that is HNO2, and dinitrogen pentoxide is anhydride of nitric acid, that is HNO3. I hope it is clear. What is anhydride means? When you dissolve this in water, they form that compound, that is HNO3. Similarly, when you dissolve this in water, it also forms HNO2. So that's why this is called anhydride. Anhydride means without water. I hope it is clear. Next question. Question number 9 or 8 or 10 we'll discuss. So question number 9 now. Question number 9 based on the aqueous solution of NCl3 is halide. The aqueous solution of NCl3 is used as first one, chlorinating agent. Generally, if you have chlorine, so you think it is chlorinating agent, but it's not the right answer. Second option, bleaching agent. So this is the right answer because from this we will get nascent chlorine. Bleaching agent, because from NCl3 you will get nascent chlorine. So bleaching agent. So answer is 2. And third option also given, reducing agent. And fourth option they are given, explosive. So answer is bleaching agent because from this you will get nascent chlorine. From NCl3 you will get nascent chlorine, which is just one chlorine and it is highly reactive. So it can attack the coloring matter and makes it colorless. Next question. So they are given the following are some statements. So which is correct? Which is correct among oxides of nitrogen? So from oxides of nitrogen, we are getting many questions. These are all. This is previous JEE mains question. So first, they are given first statement. N2O molecule. N2O is linear. Second statement, they are given NO2 is angular. Third statement, they are given N2O5 is angular. N2O5 is angular. So out of these three, which is correct? So answer is only 1 and 2 are correct. 1 and 2 are correct. And 3 is wrong because N2O5 is not angular, it is planar. It is what? Planar. So answer is only 1 and 2 are correct. Like these questions you are going to get in the examination. These are all previous competitive exams. I hope it is clear. So next question we are going to discuss now based on nitrogen compounds. Either reactions you will get or you will get structures also. Next question. Question number 11. Fractional distillation of nitric acid gives fractional distillation of nitric acid can give dash percentage of nitric acid. So we can say it is answer is just writing answer directly without writing options. 98% of nitric acid can be obtained by the means of fractional distillation of nitric acid. I hope it is clear. Next question, question number 12. In per nitric acid, the oxidation state of nitrogen is the oxidation state of nitrogen is Option 1, it is plus 1. Option 2, it is plus 5. Option 3, it is plus 7. And option 4, it is plus 3. So the formula of nitric acid is HNO4. HNO4, so it is plus 5. Next question. Next question. The starting material. This is also previous competitive question. The starting material for the manufacture of nitric acid by for HNO3 preparation in Ostwald processes. In Ostwald's processes. Ostwald's process is option 1. What is option 1 here? They have given, and I'm writing the options right now. Please note it down. Ammonia and N2O. Second option, only ammonia. Third option, A. And fourth option, ammonia and nitrogen. So answer is only ammonia because NH3 plus 5O2 gives rise to Ostwald process. So answer is ammonia. So like this questions is very, very important. So I have done maximum questions based on nitrogen compounds. So you please do further questions in your competitive books. So with this, I'm closing this class. So this session we have done compounds of nitrogen and use of nitrogen. So in the next session, we'll do about phosphorus so that this chapter will be completed. And I hope it is clear. So it's very, very important chapter and it's easy also, just only memorizing chapter. So thank you all.